Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am here with the second part of fats and oils in food products. Let's begin. Chemical modifications in fat products. Hydrogenation. Hydrogenation is a part of manufacturing process of a wide range of fat products because this reaction alters the melting point of fatty acids by increasing their saturation with hydrogen. What happens in hydrogenation? The addition of hydrogen to an unsaturated fatty acid in the presence of catalyst, which is usually a nickel, to reduce the unsaturation of the molecule and raise the melting point. And it is done commercially to make the product so that it can be consumed by the consumer as per their need. Like through hydrogenation, the liquid unsaturated fat is turned into a solid fat by adding hydrogen in it. So when we need to eat margarine, it is a type of fat, we cannot spread oil over the bread and eat it. We need a comparatively solid form of fat which can be easily spread over the bread. So making an oil suitable use as margarines and shortenings. But one undesirable result of the hydrogenation process is that some unsaturated fatty acid undergoes isomerization. What is isomerization? The unsaturated fatty acid becomes hydrogenized when a double bond may change its state from a cis to a trans configuration, or it may move to other positions in the carbon chain. So both types of isomerization frequently occurs in any fatty acid undergoing hydrogenation. Trans fatty acids. Completely hydrogenation when occur, the hydrogenated oil do not contain double bonds and thus they do not contain trans fatty acids. But the partial hydrogenation of oil may cause the fat to produce trans fatty acids. And trans fatty acid is evidence that it accumulates the low density lipoproteins, which may increase the risk of coronary heart diseases. So in the slide, you can see an image in which the diet, which is rich in cis, that is unsaturated fat, is tend to increase the high density lipoprotein, while the diet which is rich in trans fat, as we just have seen, the state of fat is changed after hydrogenation. The LDL level is raised and it actually lowers the HDL levels, high density lipoproteins. So after this consideration, the food labeling has been given a focused attention so that over the label, apart from the total fat, the trans fat should be mentioned. Why? Because of its negative health concern. Here, some trans fats are of importance, which are lactic acid. It is an unsaturated fatty acid, trans fatty acid, which is the, you can say, the isomer of oleic acid, which is usually found in hydrogenated vegetable oil, and it does raise LDLs. While the vaccinic acid is a naturally occurring trans fatty acid which is present in human milk and in dairy products such as milk, butter and yogurt, and it tends to not actually raise the LDLs. It does not give a negative impact on the lipid profile. The only difference between two of them is the difference in their configuration. So a trans fat can always be a bad trans fat. You can see the other type of trans fat, which is vaccinic acid, does not tend to raise the LDLs. Here are some fat content of foods in selected items. You can see the product of 1 tablespoon butter, stick margarine, soft top margarine, which is actually trans fat free, and margarines in the bottle. The total fat content of butter, stick margarine are not very much, but the difference, the margarine and the bottle, is quite a lot in grams, that is 0.4 gram. While you can see the other difference, the butter and stick margarine is high in trans fat, while the stick margarine is more in trans fat as compared to butter, and the softer margarines and margarines in the bottle have zero trans fat in it. So you should know as a nutrition student that how much of trans and saturated fat and total fat could be present in the fatty products. Inter and intraesterification. What is interesterification? It is the reorganization of fatty acids to form different fat molecules. It can be chemical or enzymatic. Actually, it involves a rearrangement, or you can say the reshuffling of the fatty acids on the glycerol background of the triglyceride molecule. Interesterification is catalyzed by an alkaline catalyst or by a lipase enzyme. The most commonly used alkaline catalysts are sodium methionolate and sodium ethionolate. The early interesterification process was used to extend the plastic range of lard, which can be used as shortening. But later on, the blends of different raw materials were used to change their physical properties so that they could be used as hard fat, as in the form of margarine, or it may be used as a shortening. If the fat is melted for interesterification process, all of the fat molecules are able to participate, and the procedure is termed as randomized interesterification, in which it is accomplished by using the melted fat. While the directed interesterification is the process of interesterification in which the fat is kept below its melting temperature. Directed interesterification is useful when the goal of the manufacturer is to raise the melting point of the fat, basically to improve the textural characteristics of a fat. While the intraesterification is the catalyzed reaction in which the fatty acids split from glycerol and rejoins in a different configuration, but with the same fatty acids being retained in the molecule. Fats and oils in the marketplace. Fats and today's health challenges. Many food industries and consumers now are aware of the health hazards of trans fats. So they are now they have a concern to reduce the amount of trans fats in their products because of their health risks that may involve obesity and later on all the diseases that may link to their heart. So the efforts to reduce the trans fat include the change in oil that is used, the alterations in diacylglyceride levels, and changing fatty acids in plants through selective breeding and genetic alterations. The sources are animal and plant source. Animal fats are high in saturated fatty acids and lower in unsaturated fatty acids. Then are plants lipid sources. While animal fats, the fats in animal fats include beef tallow and butter fat, which is milk fat from cattle, and lard, and also from pig, which are obviously not included in our diets. And the examples are butter and lard. While in plants, the plant sources includes olives, coconuts, peanuts. Plant oils are high in polyunsaturated fatty acids, which are valued in reducing serum cholesterol levels, like bad cholesterol levels that are, I mean, low lipoproteins which have low density. Modifying plant lipids, and these are the genetic engineering which modifies the genetic information in cells. Both genetic and plant breeding efforts are done to raise oleic acid and lower the linoleic acid levels. Sunflower oil with a high oleic acid level has been developed through plant breeding, while diacylglycerols is a type of lipid composed of two fatty acids. They are used for energy instead of being stored as fat. Fish oils. Fish oils are also a source of nutrient omega-3 long-chain polyunsaturated fatty acids include docosahexaenic acid and eicosapentaenoic acid. Both are found in fish oils. Omega-3 fatty acids helps in reducing heart diseases. The oil products are peanuts, corns, cottonseed, safflower oils, canola, olive, and soybean oils. And the ones which is used either single or as a blend of two or more, I mean that any of one can be used as a source of oil, or maybe two or more kind of oil may be blended to form a one single to make one single oil that can be used in cooking and in other cookery process. Butter is water in oil emulsion when the milk fat is churned. Margarine is made by hydrogenating plant oils. The types of margarines are regular, stick, and soft, or it may be tube margarine. Peanut butters and various nut butters are made of plant oils. As I've told you, the spreads can be of different types. Stick margarines, soft or tub margarines are prominent. Let's see what are stick margarines. These are the spreads made by hydrogenating plant oils and adding water, milk solids, flavorings, and coloring to achieve a product similar to the butter. While soft or tub margarines are the spreads with melting points lower than those of stick margarine because of a higher content of polyunsaturated fatty acid. And the third form is the whipped margarines, which are the stick margarines that have been whipped mechanically into fat form. Increased volume results in fewer calories per given volume. So here is my question that goes to you. Out of these three types of margarines, what do you think is the one that we should opt, keeping in mind that it gives us a good impact on our health? Shortenings and lard. Shortenings and lard, like oils, are essentially all fat. However, they are solids with considerable plasticity. What is plasticity? It is an ability of a fat to be spread or creamed. So, shortening are the products through the efforts of technology. The main part of their making is the hydrogenation of vegetable oils to get the desired thickness. Baked tallow is made from cattle to yield a characteristically hard fat. Substituting fats. Sometimes it becomes necessary for some health reasons that fat or oil in a recipe can be altered. Like you may not be allowed to have a fat or a type of butter which has a high amount of a margarine which may have a high amount of trans. Then you may seek to have a product which may be substituting of that particular fat product. So there are some examples which can be used for a good substitution. Stick margarines can be used instead of butter. Tub margarine can be used instead of butter and stick margarine, while shortening and lard can be used instead of butter and margarine, but not in the same quantities. So these can be used in exchange of the other product.